people, this is Data Lu, and I'm gonna go over feature importance in today's video. So first of all, what is feature importance and what is feature engineering? So feature importance is like you have all these assumptions about what would best fit in your model, but you might have a lot of variables that you think will be a good fit, but at the end of when you put it into a model, it might be overfitting or underfitting. So we want to make sure that we pick the right features that feeds into our model. And feature engineering is essentially that you pull direct metrics from your database, but then you want to do some manipulations with it so that you can get more metrics are available, and also to see, what variations of the metric will be better for you. So before we go into a feature selection actual process, we need to come up with the features first before you can actually select the features you want, right? So then the first thing I'm gonna go over the two examples of what to think about for a data set or data you can collect for your feature. So first example I'm giving is if you're predicting a price of a used car, there are many pieces to think about. So like you first of all, different brand will have different prices, such as Lexus is not gonna be the same price as Toyota. And then even within the same brand, like Toyota, right? They have different models such as Corolla, Camry, and that will make huge difference as well, right? And then you also have the year of the car. So like a car that's made in 2003 would not be the same price as 2010. And then there's also might be seasonality. So depends on the date of the car is purchased, because these auto dealership might have pressure to have different hit the sales number. So then maybe like end of a month they actually will lower the price because they had to hit a certain number of cars they sell. And then it also depends on location, such as Silicon Valley is always more expensive than other areas. Second example I'm gonna give you will be a classification problem for spam or ham email. And when you think about it, you have to kind of think of your observation of what the spamming email looks like. So maybe the username is suspicious, or the email address doesn't match with the official email from, like, let's say the bank email address. It has certain keywords in it. And then you can also think of the body text, where the body text might have weird characters, or like just a link and has no words, or has like certain format of the body text. And then you can also think that, okay, so like the spamming email might be sent by robots, so then maybe the send time is very specific, has a trend, and maybe that's also a good indicator. And then another one would be number of links. So potentially these spamming emails really want you to click on one of the links and then to collect your information. So maybe they'll have more of the same link, or these links are suspicious. Or the other one will be looking at their profile completion. So maybe these accounts are created by robots and they don't care about any of their profile, so that they have like no phone verification. So after you have collected all the data that you think will be very relevant to your model, the second step will be checking your data. And for classification problems, like the spam or ham example that I just gave, you really want to make sure that your data is balanced. And what do I mean by that is your percentage of your whole data set, a percentage of spam and ham should be fairly equal. And let's say, very likely that your data set might show like 90% ham and 10% spam. And what you can do is to reduce the number of ham email, or like try to synthetically match them to your number of spam emails that you have, so that you have roughly, close to 50%. The good thing about that is that your model is not going to just favor one classification versus the other one, since you're a binary. So that's very important for classification problems. And then the second thing you want to do is to check your percentage of nulls. So we want to make sure that our features that we feed in are not just going to be a lot of blanks, because blanks wouldn't tell you anything about, this person, and like does not fit into well into your model. And then the other thing is you want to check to make sure that all your features are not super highly correlated. Building like a kind of like heat map, you can do this in R Python, or you have a Seaborn heat map. So the second piece is that, after you have all this data and you remove the features that you think they're not good indication of your model based on the nulls and then correlation, the second thing you're gonna think about is missing value. So even if you try to remove the variables or features that has a high percentage of nulls, there's still going to be a lot of features out there that's, maybe show 5% null or 3% null. And what are you going to do with those missing values? So one thing, super straightforward, is just drop them. Just don't even use them. But then you might think, oh, but then I'm going to, lose some data values. So what can you do with that? Or you might have new users or people who just don't have those data points yet, and maybe you should exclude them. But the other thing you can also do is to use some sort of mean, median, or mode. I personally probably prefer mean or median, but then you can use mean or median to fill in these blanks based on, let's say, for the used car model we just talked about. You might want to do the mean or median based on the specific brand, specific model, so that you're not just taking the mean or median of the entire data set. The last one is the most complex way of filling in your missing values. So I guess, yes, you can build another model to fill in your missing values, like a prediction model. And it can be something fairly straightforward, like a linear regression model or something. But what they're trying to say is that you're using a model to predict, what's likely of the value for this missing value, which I guess should be a lot more accurate, because you're not simply just taking the mean or median, but it will take a lot more effort. So depends on how much time you have, and you might want to consider just using mean and median or a prediction model, or just simply drop off. So for feature engineering, I think the most basic and straightforward one would be converting your categorical data to numerical values. And what I mean by that is when you have, the used car prices example, that you might want to convert your brand, such as Toyota or Lexus or Ferrari, whatever, and convert that into just like 1, 2, and 3, so that you don't need to necessarily to know that what brand it is, but you want to be able to differentiate them using numerical values, and usually you use integers for that. Or the other one would be, since you have the historical data for like the exact purchase date, you might want to convert it into maybe first half of the month or second half of the month, or even like what quarter it's in, and that will tell you a lot of information that you don't need the exact date, because that information might be too granular, and that doesn't give you like a good idea of how the data will be different. Depends on the date, so exact date. So you want to like kind of do it based on a month or the quarter, or like give it first half and second half of the month, because dealers have different sales pressure beginning of month and second half of month. And then the other thing will be location. Like, let's say you have exact location of a dealership that where the used car is purchased. First of all, that's a little too granular. It's probably not very helpful for you. And what you can do is probably convert it into zip code, or even like the region within the states or something. That it can give you a good idea, but it's not so granular that it doesn't really tell you much. And then for our spam and ham email classification model, the feature engineering we can do is like, instead of just having, well, first of all, having a username doesn't tell you anything, but if you can calculate like percentage of characters that has the special characters like ats or like, dollar sign, percentage sign, and the username, that'll be helpful. Or even go into, the length of the username. And then the other thing would be like, instead of having like body text, you actually want to count like the number of links in the body text. That would be kind of helpful. So like you're trying to have all these categorical data that you have and try to build metrics around them and like make it into numerical values that you think will actually be helpful to your model. And that you might even have, for the send time or the email send time, you can actually create kind of like a boolean if to see if the email is sent at like exactly 1 o'clock or 2 o'clock, so that it's a very specific timestamp or not. But that kind of really depends on, you have to go look into your data and see if that's even a trend. So after you have to collect all your data and did your feature engineering and you have a finalized data set, and what do you do after that? So after that, you will have to feed this into your selection model. And how you would do that is, you will pick maybe a couple different models that you have in mind that's related to regression. And for example, the two examples I picked here are like linear regression, XGBoost regression. And of course, there are many other regression models out there, but I'm just giving two examples and then show you kind of like how, different model will actually give you different results. But the rule of thumb in general, when you see a feature selection model output, is that the further away from zero is actually definitely better. And that applies to almost every model. And then next slide, I'm going to go over a classification, which has logistic regression, which has positive and negative values, but that'll be different. So for linear regression, we definitely want to remove the zeros. That means it's the coefficient is zero, which means that that variable is like completely does not help predict your y. And then for XGBoost regression, in general, it's higher the better. So you can see that feature 3 is definitely better than feature 2, feature 1. And you can see, based on which model you run, you're always going to get different results, even if with the same data set. So for me, my rule of thumb is always, you gotta just try it out. Like you gotta just, test it out to see. Let's say you pick the top, let's say out of 100, you take the top 5 or remove the bottom 5 to begin with and to fit into your model, and then see if the accuracy metric actually improves or not. And that will be a good indicator of which model or which feature selection model would work better for you. And that kind of also tells you like maybe you should use XGBoost regression. A classification model like the SPAM and HAM, you might end up looking at like bar graphs like this, has 0 to 3 features, and each one will tell you for logistic regression. So the rule of thumb is still further away from 0 is better. So even if it'll show negative, but what it means by negative is like it's actually like, let's say you have SPAM and HAM, so that the negative value might be better indicator for SPAM, or the positive value would be better for HAM. So like it's just that it has positive and negative value to help you indicate which binary classification that it's better for. But in general, if it's like closer to 0, that you should still remove it. And you can test it out to see, how is this different from your random forest classification. So actually, the example I give here is showing that feature 2 is the worst for both models, which is great that they're kind of aligned. But if they're not aligned, then you might want, like what I said earlier, try it out. Just pick the top 5 or remove the bottom 5.